Hello all, welcome to part 15 of the Security Tube Metasploit Framework Expert. In this video, we will look at how to use Metasploit and backdoor executables. This video is part of the Security Tube Metasploit Framework Expert video series, and you can have more details on securitytube.net/smfe. Our certifications are taken by students from over 30 plus countries around the world, and this free video on SecurityTube is in line with our vision to provide free yet quality InfoSec education to one and all. Now, till now what we have seen is that we've exploited services, we've done client-side attacks. However, after the attack was successful, we used a payload to gain access to the system. Now, what if we could backdoor executables or take the payload and create a standalone executable of the payload itself? This is what we are going to explore in this video. To do this, the tool we will use as part of the Metasploit suite is MSF Payload. So let's see how we can use this. So let's run MSF Payload with the -h command to look at all the options. In order to convert a payload into an executable, the first step is to actually figure out what are the options the payload requires. Right, so let me type in the payload name, which is Windows Meterpreter Reverse TCP, and the capital S will give us a summary of the payload and the options it requires. What we will do after that is, after filling up the appropriate options, we will use the X option to actually create a standalone executable from this payload. So it looks like the only option we require is the L host, which is basically the IP address of the attacker machine, which is 192.168.1.10 in our case. I use the X option to get an executable, and basically we will call it reverse tcp.exe. What we will also do is start a web server by using Apache. And create a directory within it called Trojans. Right, and now we'll copy this reverse.tcp file .exe into var www trojans. Right, now basically this is nothing but a Win32 executable. And once you execute it on the attacker machine, we need the appropriate handler to take care of this. Right, so we'll set all the parameters up, and then we'll wait for our reverse TCP connection. Now on the victim machine, let's start Internet Explorer and go to our web server inside the Trojans directory. Now this could have been a link to an executable file for download or packaged with an existing executable, tons of ways. What we are not concerned with in this video is how the file got transferred finally to the victim. The assumption here is that the file got transferred and we are about to execute it on the victim, and if it does, is it possible to get a quick backdoor access. So now if you notice, we are still waiting, and as soon as we run reverse TCP and go back, you would notice that we got a Meterpreter session on the attacker machine, right? And this basically is on the victim computer. Oops. Right? So this is how we can go ahead and get a Meterpreter session by converting a payload into an executable. Now the next variation which we will look at is to use an existing executable and add our clone on top of it. So for that, what I've done is I've already copied notepad.exe on our machine. This is the standard notepad file on any Windows machine. And then what I will do is I will use MSF encode in conjunction with MSF payload. Now MSF encode basically encodes the payload output and allows us to do a ton of interesting things. So what I'm going to do is pipe the raw output of MSF payload into MSF encode. The output I want is in exe format, and basically the template I want to use is basically root notepad.exe. The number of times I would like to encode with the default encoder, which is Shikataga 9. We're going to scroll up here, is let's say 10, and the output file I want is notepad_trojan.exe. Now in this specific variation, what happens is the original notepad file does not run, but the look and feel and all of that, which is basically the resource file, everything remains the same. So visually it looks as if it is notepad. We'll see what I mean in just a second. In the meantime, let me also start the payload handler on the other side. This would take a second. Let me copy notepad_trojan to var www trojans. Let's go back to the victim computer now, refresh the web server page, download notepad_trojan.exe, and now let me run it. So before I run it, you notice this looks exactly like Notepad. So what we've done is all the look and feel, everything is the same. However, the moment we run this program, it basically connects back to our exploit handler, which is waiting on the attacker machine, right? Now let's do a third variation in which we try and keep Notepad alive as well. This is done using the -k option, which is keep the template working and run the payload as a different thread. Now, a word of caution, this does not always work properly. What I've seen is some templates fail to work in this way. Actually, I don't want to overwrite the old file, so let me just say working. This is easy. Takes a bit. In the meantime, what I want to point out is if we had done the same thing on a computer which has one of the latest AVs like AVG, right? Let me just download both the files. Typically what would end up happening is these would be detected. So if you notice, AVG detected it. The first one, reverse TCP, it's been removed. Similarly, AVG detects the second one as well, which is sad, right? Because which means in the presence of an AV, the plain vanilla version of the attack we just spoke about doesn't seem to work. Now what I'm going to do is copy the Trojan underscore working.exe to var ww Trojans, right? I'm going to continue running my exploit handler here. Go back to the original machine which did not have the AV. Refresh, download this working copy, save it, and let's see what happens when we try running this, right? So this is the one. Let's run this. And now if you notice, we got a Meterpreter session, while this seems to be our normal notepad file, right? Everything looks okay. Now, what I want to point out is this plain vanilla hack does not work properly uh, in many cases, right? Especially when there is an antivirus present there. So let's move to the AV mode, refresh the page, download the working copy of this Trojan and see what happens. So now if I try running this, looks like the AV found it out once again. Now, AV evasion is a topic in itself, and typically the idea would be to write your own encoder, your own packer, mix and match things up. In some cases, you may be able to just use an existing packer like UPX and pack a file and make it undetectable. So let's try and see if it is possible with this one. So let's run UPX. Let's do the maximum compression possible. The output file would be notepad underscore Trojan working underscore upx.exe, and the input file would be notepad Trojan working.exe, right? So compression has happened. Let's copy this file to var www Trojans. Our exploit handler is already running. Let's see what happens. So this is basically compressed with UPX. And if I try running this, if you notice this time it does not give me any errors or any issues. And when I run this, fantastically it just seems to run. And if I go back here, if you notice the exploit is currently in progress of getting downloaded, right? Seems to be some small issue here or there. What I've also done is I've played around with a couple of other files with just modifying with UPX. So one of the other files which I have is called notepad2-upx.exe, which was again something I used. Right, let me kill this handler. For some reason the stage did not get completed. And start the exploit process again. And if you notice in this case, later on it was able to detect that something was wrong even though it allowed in the first instance, right? So if you notice, this one did not work in the second part when we were downloading the DLL. Now interestingly, the one which I just saved, which I had done on a previous run, seemed to work without any issues. So this is the one. Fair enough. There you go. However, interestingly, again in this case, it seems to be detecting that something is wrong, even though the first part of the handler seems to have run. One of the things which I suspect is maybe our handler is not working as required, which typically should not be the case though in most cases. Let me try and compress. So one of the other interesting ways which you could try uh, is actually by increasing the number of times you play around with the encoding Shikata Nai and then see what happens. So what we're going to try now is encoding it 15 times and then packing it and see if this changes anything else. So I can go back here. So AV evasion is a topic in itself, to be honest. It's not something which is very predictable. In some cases, something which may evade one AV may get caught by another AV. The right way to do this is probably write your own encoders, even encryptors, which encrypt your actual payload and then decrypt it in memory and do a bunch of other wacky things. Right, now let me go ahead and run UPX. And basically this is the input file. This is the output file. Done the compression. Let me copy this out. Trojans. Now let's run our handler, which is already running here. You can go back here. Let's download this, save it, close. Once again, no error at this point. However, it has figured something out here, and that's why the stage is not completing. Now, what I had done in a couple of previous runs, as I said, because this is Shikata Nai is polymorphic, you could see a lot of interesting things happening. Already has found a bunch of stuff here. I had an interesting little version of Notepad which I had created during one of these runs without writing my own encoder, which seemed to work fine. So let's go ahead and try this and see what happens. Again, no complaints, and this one seems to generate no issues at all. But if you go back, we have a Meterpreter session. So basically what you need to do is try various combinations. This is the plain vanilla way, not the best way to evade AVs, to be very frank with you. What we are doing is, because Shikata Nai is polymorphic, you end up having different outputs every time and you pack it, which again looks different. However, the AV would like and probably figure out the stub which does all the unpacking and decoding and then tries and figures out the signature. Now, if you play around with it for quite some time with different combinations of packing levels or different packers along with different encoders, different number of times you encode it recursively, it could work. But the better way would be to write your own encoder or encryptor. Now that we have broken into the system, we can do what we want. And if you remember one of the previous videos, we could now kill the antivirus using that technique and then take control of the whole system, right? Anyway, that's all for this video. Looked at all of this. So this video was part of the SecurityTube Metasploit Framework Expert video series. Check us out at securitytube.net/SMFE. And thank you very much for watching. Please leave your comments behind.